Alright, so like I said, last class we talked about writing names from formulas of ionic compounds. This time we're going to write the formula from the name of an ionic compound. Now we're going to just first start with the charges, and then we'll actually move on to actual names, okay? So remember, in an ionic formula, the total number of positive charges must equal the total number of negative charges, okay? So you must add cations and anions until the charges cancel out. So if the overall negative charge is -6, the overall positive charge has to be +6, okay? So what you're going to do is you're going to be adding cations, anions, until you get those overall charges to be the same. So our first example is magnesium and chlorine. Now what is magnesium's charge? +2. Okay. Now, what's chlorine's charge? -1. Okay. So we have an overall charge of -1 here, an overall charge of +2. So what do I need to add to make them equal? So the goal is to make these two, the overall negative and the overall positive, equal. Okay. So what I'm going to do is I have a -1 here, a +2. I want to make this -1 a +2, okay? So I'm going to add another chlorine, and what that will do is that will make that -1 a -2, right? And so here we have +2 on this side, 2 -1s on this side. So that makes it an overall +2, overall -2. So when I'm writing the formula, it's going to be Mg, and when writing this formula, you always put the metal first. For ionic compounds, metal always goes first. So it's going to be Mg and then Cl, and then there are 2 chlorines. Okay? So think of it kind of like puzzle pieces. Okay, so here I got some puzzle pieces. Here I got magnesium. So magnesium has 2 arrows because it has a +2 charge. Okay, and it wants to have little spaces to fill in. Okay, so we have chlorine, which has 1 little space. 1 arrow space, okay? So chlorine, and it's because it has a -1 charge. So chlorine is going to come over here, and magnesium is going to fill in that 1 space. Now magnesium still has 1 more arrow it wants to use, right? And so what we're going to have to do is we're going to have to take another chlorine that has a -1 charge and plug it into that space, okay? So magnesium +2 has 2 arrows, and then we have 2 chlorines, each with a -1. To kind of balance out those charges. Now, I couldn't split magnesium in 2, right? So when I had this chlorine here, when it was just chlorine, just 1 chlorine, I couldn't take that off and rip it in half and make it fit, right? Just like when you're doing a puzzle, you can't just take a puzzle piece and rip it off to make it fit because it's going to mess up the picture, okay? So here, we can't just rip the magnesium in 2, so we can add another chlorine to balance those charges out, okay? So now let's look at aluminum. So aluminum has a +3 charge, okay? Now oxygen, what does oxygen have? Oxygen has a -2. Okay, oxygen has a -2 charge. So we have a +3 and a -2. Now this was not as apparent, okay? So here I have a +3 and a -2. I can't add anything to the negative side to make it +3 because, again, I can't force oxygen to have a -1 charge, can I? I can't just add an oxygen with a -1. I have to add an oxygen with a -2. But when I do that, that changes my overall negative charge to a -4, right? So now I have a problem. Now my negative side is bigger. So what I'm going to do is I'm going to add another aluminum. Now, can I add aluminum +1? No, it has to be a +3, okay? +3, that makes that +6, okay? So now I have to add another oxygen. Now when I add another oxygen, -2, -2 plus -2 plus -2 gives me a -6. And now they have canceled out, right? Okay, so my formula is going to be Al2O3. Okay, Al2O3. Let's cancel those out. All right, so looking over here, you'll see that I have an aluminum. And aluminum +3 has 3 arrows. Okay, And then I have an oxygen with a -2. Now oxygen can take 2 arrows. So when I put those together, I still have 1 arrow left, right? So I have 1 positive charge left to cancel out. And so I gotta take another oxygen, but again, I can't just split this oxygen in half to make a -1. It always comes as a -2. And so when I do that, now oxygen needs another arrow, okay? So I'm gonna add another aluminum, but again, aluminums only come with 3 arrows. It only comes with a +3 charge. So when I do that, that helps the oxygen, but it doesn't help the aluminum. The aluminum still has 2 more positive charges it has to balance out. And so I add another O2 with a -2 charge, and that balances those out. So now we have 2 aluminums, each with a +3, and then 3 oxygens, each with a -2. Okay? And so those will cancel each other out. So calcium and sulfur. Calcium's charge is going to be what? +2. And what is sulfur's charge? -2. Now, do I need to add anything to this? No. Okay, they already canceled each other out, right? They fit perfectly. Perfect puzzle pieces. So it's going to be CaS. 1 calcium, 1 sulfur. Okay. Next one, we also have calcium. So we did calcium +2. Now, what is ASO4? Arsenate. Okay, it's a polyatomic ion. Now remember, the 4 does not mean I have 4 arsenates, right? That is part of arsenate. And all of arsenate has what charge? -3. Okay? So we got a +2 over here and a -3. So what do I need to do to balance this out? Hint, if you don't know where to start, just always start with the lower number. So my lower number here is a +2, so I'm going to add a calcium. But again, I have to add a calcium +2. That changes it to +4, right? So now I'm going to go to the negative side, right? Add another arsenate. That makes it -3. That makes that -6. So now I've got to go back to the calcium. Add another calcium +2. That makes that +6. Okay. So my formula is going to be Ca3, because I have 3 calciums, and then I have ASO4. Now, when I'm writing a polyatomic ion, if I have more than 1 polyatomic ion, I have to put them in parentheses. ASO4, 2. I have to put them in parentheses, because if I did ASO4 and then 2 without a parentheses, it looks like I have 42 oxygens. Okay, I don't have 42 oxygens, I have 2 arsenates. Because remember that 4 is part of arsenate. It's just as much a part of arsenate as the A is part of calcium. Okay, so that number never changes for arsenate. Now the next one, I have aluminum sulfite. So that means I have aluminum, which is a what charge?
3.
+3. Now sulfite is going to be SO3 what? SO3 -2. Okay. So we got a -2 here and a +3 here. So what do I need? 2 aluminums, making that +6, and 3 sulfites. 2 aluminums and 3 sulfites. So I have 2 aluminums to make a +6, and then 3 sulfites to make a -6. Do y'all see how we made that conclusion? Okay, because the more you do this, the more you can just look at it and be able, oh, I need 1 more of this. I need 3 more of this to balance it out. And so that's going to be Al2, SO3, and then remember close parentheses, 3, because I have 3 sulfites. I'm going to have 33 oxygen. Okay. All right, let's look at the next one. Silver. All right, so remember I said that every transition metal needs a Roman numeral. Well, again, there's always exceptions to the rules, and we kind of touched on this last class. I'm going to touch on it more in this class. So, if you look, zinc, cadmium, silver, and scandium, they all have charges in their corners, and they all have one charge. So what that means is that when you see silver in a compound, like silver sulfate, it's not going to give you a Roman numeral, because they assume you already know that it only has one charge. Even when you look on your periodic table at your desk, if you look in the corner of silver, you'll see it only has a positive 1, okay? So, for those, they're not going to give you the Roman numeral. They're just going to assume you know. So, I know that silver is positive 1, because I can see it in the corner of my periodic table. And then sulfate, again, sulfate SO4, sorry, that should be a positive 1, okay. Sulfate is SO4 negative 2. Okay. So I have to add another silver to balance, silver positive 1 to balance out that negative 2 sulfate. Okay. So my formula is going to be Ag2SO4. Now, if I only have one polyatomic ion, I do not need parentheses. Okay, you can put parentheses if you want to, but you do not need them. Because I should know that sulfate's SO4, that does not mean I have 4 sulfates, right? That means it means it is sulfate, not sulfite, which is SO3, okay? So that's just something you need to be able to recognize. That, again, that's why you got to memorize these polyatomic ions. All right, now, here we're to transition metals. These transition metals have Roman numerals. What the Roman numerals mean is it's the charge of the metal. So 2, the Roman numeral 2 means that my nickel has a positive 2 charge. So when I'm trying to balance out those charges, nickel is going to have positive 2. Now nitrate is going to be NO3 negative 1. So what do I need to add to balance it? Yes, 1 more nitrate to balance that out. That makes the overall negative charge negative 2, the overall positive charge positive 2. So my formula is going to be NO3, 2. Okay? NO3, 2. Yeah.
Like, so if it's always going to go like to the first one on the list?
Yes. So the Roman numeral is always just going to go to the metal. It's not going to go to the non-metal. Okay? So iron 3 chloride means that iron has a positive 3. Okay? So it's going to be Fe positive 3. It also doesn't mean that I have 3 irons, right? Here I only have 1 nickel. Nickel 2 doesn't mean I have 2 nickels. It means I have my nickel is positive 2. Okay? Then chloride. What is chloride? Is it? Yep. Chloride is just chlorine. Okay? So remember, IDE, other than hydroxide and cyanide, chloride, IDE means it's just the element, so it's just chlorine. Chlorine, negative 1. Okay? And so I need to add 2 more chlorines to balance out that positive 3 charge of the iron. So my formula is going to be FeCl3. Okay? Now, the last one, 10,4 sulfate. So this is 4. The 4 means that the 10 has a positive 4 charge. Okay? 10 is Sn. Sn, positive 4. Now, sulfate is SO4, negative 2. So what do I need to add here? 1 more of the sulfate, right? So that's negative 2 plus negative 2 gives me negative 4. Balanced out with a positive 4. Sn, SO4. And in this case, I do put it in parentheses, right? Because I have 2 of them. Now, when I'm writing the formula, do I put the charges in the formula? No, because they're gone, right? They canceled out. Look, I made a pretty puzzle piece. Okay? So that's what that means, is that it's all balanced out. I don't need to include those charges. Okay?